Hello. So in high school, I thought that, science was just a class you had to take to graduate and just pass it and you'll be fine. So I didn't try whatsoever. I just made sure I had a good grade in the class so I could graduate. But then when I took this class, physical science, I realized that science is actually all around us. It is basically our life. So in our handy dandy unit, energy-based models of interaction, I realized that it is basically all around us, and it just cleared up my mind a lot more. So here is Sammy, Sam, and me explaining more about the interactions that we have learned. The first one is contact push-pull interaction. It is when two objects in contact push or pull on each other. If this is the only interaction between the two objects, the speed of one or both objects will change during the interaction. So in class we use the cart, but here I don't have one. So I'm gonna use this Dark Blue Craft Smart acrylic paint to do the job. So we can put it on the floor, and right now it's at constant speed of 0 because there's no interaction. So once my hand interacts with the paint bottle, it goes at a constant speed till it stops. So another form of contact push and pull interaction is with friction. Instead of me using my hand and a cart, I could use a ball in my foot. So as the one and only Neymar does, he kicks the ball. So once I kick it, my foot loses or decreases in chemical potential energy. And then once I kick the ball, which is a disco ball because I don't have a soccer ball here because I'm in college, it increases in kinetic energy.
Heat interactions are when two objects that have different temperatures interact, and as a result, thermal energy is transferred from the warmer object or the energy giver to the cooler object or energy receiver. And this causes a decrease in thermal energy of the energy giver and an increase in thermal energy of the energy receiver. For example, with this cup of hot coffee is the energy giver. When I put my hands around it, there is a transfer of thermal energy to me, the energy receiver, and that's a heat interaction. An electric circuit interaction is whenever there is a source of electrical energy and that energy is transferred by being connected to an electrical device to complete the circuit. For example, when I plug in my computer, the energy giver is the charger, and it is decreasing in chemical potential energy and increasing in thermal energy, and that's being transferred to my computer that increases in thermal energy to complete the circuit.
Light interactions are something we use every day. Through electric circuit interactions, lights are turned on in our houses, in school, basically anywhere we go. But these lights also cause light interactions. When lights are on, the bulbs are emitting visible light. When this light hits another object, such as my eye, there can be some changes in the object. When your eye absorbs this light, it allows you to, quote-unquote, see the bulb. Or if you're wearing dark colors like black, your clothes will actually absorb this light. This is why performers and actors sweat so much while performing, because of a spotlight and the strong stage lights. This shows that there is energy being given and received through light interactions. Light bulbs become so hot that they are transferring energy to surrounding objects through light interactions and heat interactions working together. As I said before, when light interacts with dark-colored objects, they will absorb the light and increase in temperature. But when they absorb with light-colored objects, they will reflect most of the light. So, I have two tank tops. I have a black one and a white one. And you can see when I shine the light on the black one, it doesn't really light up too much. But when you shine the light on the white one, it becomes a lot brighter. A sound interaction is a set of push-pull interactions where energy is transferred from the source through the air to the sound receivers. A good example of this is a fan. According to page 46 of the Energy-Based Models Unit, the purpose of a motor or fan is to transform energy from an electrical energy source into the kinetic energy of the air through a contact push-pull interaction. So, when the fan is plugged in and you turn it on, the blades begin to turn. After the blades begin to turn, the fan starts to warm up and any air in contact with the blades begin to change temperature. The fan then reaches its maximum speed, and the surroundings begin to reach a constant operating temperature. It is also a common misconception that the fan is cooling the air. This is not true. You cool down with the fan on because when the air moves past you, it is able to remove energy through heat interactions. Thanks for watching!
you.